Our experiment is the effects of microgravity on the growth of ryegrass seeds. We are from Florence and Gaudineer Middle School in Springfield, New Jersey, and Springfield is located about 20 miles west of New York City.
We are the 7th grade team from FMG. On my right, I have the co-principal investigators, David Arias, Jeremy Dash, and Daniel Munoz. And for the co-investigators, we have Timothy Burns and me, Antonio Nachi. And our teacher facilitator is Mrs. Allison Gillen, but she cannot join us today.
Our research. Our research question is, what are the effects of microgravity on the growth rate of ryegrass seeds? In the absence of gravity, what direction will the roots and or stems grow? Well, we do know a couple things. Seed roots respond positively to gravity, so they grow down. Stems grow negatively to gravity, so they grow up. The germination process for the ryegrass seeds is approximately 5 to 12 days on Earth. And will that be the same microgravity? We will use a concentrated salt solution as a fixative to stop the growth of the seeds at the end of the experiment. The importance of the experiment. This is a good topic for multiple reasons. Plants are the base of the energy pyramid. They're able to photosynthesize, making food for themselves and as well for all other consumers. They also provide oxygen, which we humans need because we need it to survive. So understanding the reaction of plants to microgravity will help as we try to live outside of Earth. Our salt solution. For our fixative, we use salt as it triggers a hormone in the seeds, which prevents it from stop growing. We found an article by Dr. Gaudineer and the using of concentrated salt solution and its effect on seed growth. We even contacted him, and he was able to give us the concentration we should use for our experiment. In the pictures, on the bottom left are seeds that we use the salt solution, and in the bottom right are seeds without the salt solution. We'll use this to make sure we don't receive any inaccurate measurements from the end of the experiment to when we receive the seeds back in Springfield.
Hypothesis. Our hypothesis for our experiment is if we send ryegrass seeds up into microgravity and only give them water, we think that the seeds will grow the same because we're only giving them water, which is the primary start to their germination process. And while the seeds are in microgravity, we will make sure that they receive enough water to start their growth process. And when we were in our class, we tested the amount of water we should use. And the first time we tested it, we added too much water, so all the seeds drowned. And then we tried it again with too little water, and all the seeds, they dried up. And so finally, we were able to give them just enough water to start growing and remain moist during their growth period. So hopefully that will remain the same on the International Space Station. Our fluid mixing enclosure, or type 3 FME. In volume 1, we are going to put seeds in our growth chamber, which we are using a cotton gauze. And volume 2 is going to hold our water, which will start the seed germination. And volume 3 is going to be our salt solution, which will stop the growth of the seeds. Materials. The materials that we are using for our experiment are cotton gauze, ryegrass seeds, water, and a concentrated salt solution. One of the challenges in our experiment was to find a way to let the seeds grow and have some space. And we needed a way so that they can be organized. And we first thought of cotton, like cotton balls, but it was too hard to fit them in our small test tube. So we decided on cotton gauze, so we got some from our school nurse, and we were able to cut them up into little strips and embed the seeds, like the photo. And this way, we can keep track of all seeds and make sure that they are all in line.
On the International Space Station, 9 days before the seeds return to Earth, the astronauts will release the water into the growth chamber. This will hopefully begin the seeds germination process. 5 days after that, the astronauts will release the salt into the growth chamber. This, we plan that will stop the germination process so we can compare the results from space and in our classroom. Our expected results. We have experimented in our classroom lab and found that 1.5 milliliters of water is the best amount. It keeps the seeds moist throughout the duration of the process. The seeds' roots respond positively to gravity, which means they grow down. The stem grows away from gravity, which means it responds negatively. We are wondering if the seeds and roots will respond the same way on International Space Station. Back home, we performed the same experiment in the classroom lab so we can see what happened to the seeds. We are interested to see if microgravity changes the color of the seeds, the direction of the seeds or stems, and the mass of the seeds. These are our acknowledgments, and we'd like to also thank Mr. Gula and our teacher facilitator, Mrs. Gillen.
Do we have any questions for this team?
I'm Emma from New Jersey. Why did you guys choose to use ryegrass or rye seeds?
When we were brainstorming ideas, we thought of the idea to use grass, but we didn't know exactly what type of grass we should use. So when we researched, we saw that ryegrass, it takes the least amount of time to grow, since the experiment would only be on the space station for such a little time. So.
I'm Bailey from Texas. Do you think it will change the time? Will microgravity change the time for it to grow? Do you guys think it would?
That's a good question. And we don't exactly think it will, because we were able to test it, but it could change, and so, yeah.
I'm Carolyn from New Jersey. So will your experiment be in the sun? It won't be in the sunlight, correct?
No, it won't be in the sunlight, but we tested the growth in the closet, so the results would be the same because it was in the dark.
And did it grow in the closet?
Yes.
Thanks.
Sorry. I'm Subi Lumala, and I'm from Seattle. So question, why did you use the salt solution instead of just a fixative?
So we were researching affordable solutions, and a bunch of them we looked online were several $100s, and we were just looking around, and I found something on a website from Carnegie Science Institute, and somebody did a experiment in 2013 to prove that the seed germination could be stopped by the salt solution.
Hi, I'm Audrey from Seattle. You didn't mention really where you're getting your water, or where you're getting your water from. Is it just tap water, or?
Yeah, it's just tap water.
Okay.
It's nothing special.
Okay, thank you very much.